as we have seen, static, dynamic, and which is also called NAT overload. We have seen theory about these understanding. We have understood about those different NATs. Static NAT is usually used for web hosting, one-to-one, which is used for web hosting, and others are used in the networks. And most of the NAT types that you see in your home networks is a PAD, which is a port address translation, also because as NAT overload. And let's see about let's see how we can implement the static NAT. And we also have seen the terminology about inside, outside, inside local, inside global, outside local, outside global. And so for that, let me take a router. Okay, it is considered as a consider this router as a local router. Consider it as a R. You see, okay. And let me take a one system, one server, which is I'm implementing NAT. Okay, and side, and let me take another. Okay, here I'll take two routers for a better explanation. I'm taking another PC here, consider it as a home, and I'm taking another router here, this, take this router. Okay, so which is consider this, call this one R2 and R1. Okay, so how do you connect, which is the same, which how crossover and right? How do you use crossover and strike? Crossover is for same devices. So here are the cables we have. So here is the copper crossover cable, which is used for a same type of devices. I'm using. Consider router system also. We need to assume system PC or server. We need to think of them as a router. So in such a case, it is like a same between same device, between router and router, or between router and PC. We would be using a crossover cable. Yeah, and same here. Here it is copper crossover, and same cable goes to copper crossover. Now done. Okay. So we need to set this thing. We need to configure this. So first let's configure, before we configure, let's make things clear here. Let me draw a circuit. selecting this white color. Okay. And, okay, looks great, I think. So here is the what we have is in the middle internet. So this network, random network I'm choosing. 168.168.4.0 by 2, or call anything 4.5.5.0 by 224 network it is. And here IP of server, consider IP of server 172.18.32.4 by. Okay, so we can take we have only one server. If you go to util tools, we have, you know the drill. If you take 30, you will have a, if you take 31, you will have two IPs. If you take 30, we don't need much addresses there. I am taking 252 subnet mask. So which will give us number of usable hosts too. Okay, so I can take this. I hope you understand this one. I can take this 250. Okay, so which is 30, right? Okay, now IP of here, what is the IP of this one? We can assign. If we take a 1, it must be 2 here. Okay, why? Yes, the range, it has to be 2, as you can check that range here as well. Okay, okay, you can see that we can use usable addresses from 172.18.32.1 to 172.18.32.2. Okay, and now yeah, which is great. Now let's go and configure our route. How do you configure this one? Let me increase the font size. These frequencies. It must be, I think now it is fine. Now can you see it better? Okay. Yes. Options and yeah, here. Let's okay. So enable com P, okay, and yeah, interface FA00. Now configure that interface IP address, okay, and which one? 192.168.5.1, 255.255.255.0, and no shut. Okay, it's back. Okay, now exit. Now select the interface, another interface FA01, and assign IP. So it should be one of the network. You can just this is one network. Do you understand that thing as well? This is one network. You can select, yeah. We can choose the set. And one, yeah. And dot the how many addresses we need there? Two addresses. I can use the 10 block. 10.0.0.1. I need two addresses. So this is you can select anything. 10.5.0. So what are the usable addresses? 1 and 2. Okay. And dot. So what is the network address there? Which is 10.5.0. Network address means first address by 30/30. So enter that network address here. 30. Okay. Yeah. So let's configure that one. So IP address IP IP address 10.5.0.0 to yeah 1 0.1 2 no shit. Okay, and exit. Okay, so it is done. Now go this one, select CLI, and we need to enter enable conf, okay, and interface FA01, okay, IP address which is 10.5.0.2 2 no set. Okay, now it is working. Now it's a select another interface FA0 FA0 00, okay, and IP address, okay, 172.18.32.1 2 it is also no shut, and done. We are done. We haven't added, yeah, we haven't added routes. So just configure the IP. Is we can choose to use the DHCP. So we can use static since it is single server 52.2. 62.2.2.2.52. The default gateway is 172.18.32.1. Okay, and same here. Let's configure the static IP for the PC, which is 190.168.5. Uh, 5.1 we have given for a router order. Okay, we can view 2 or 4, anything. And what is gateway? So what is gateway IP? 1, which is the router IP. Let's close this one. Now check, we haven't added any routes, so we would expect this thing to be failed here. You can see here already failed, but this should work till here, and this should work this way. Now configure default route. Okay, so what is the process to? Is which router it is? Yeah, that one route. So where are we now? Is it okay? It's stuck. So we are in a global configuration mode. Okay. Show IP route. Sorry, we should be in privileged exit mode. Let's exit this. Show IP route, which shows. Hello, show IP route. What do you see there? C stands for connected. Okay. So we have configured. So there are no routes, right? There are no routes. So we want to configure the default, which means that what is the default? Another name, which is also called gateway of last resort. It is also called gateway of last resort. So which means that here for PC and system server we connected the default gateway. It is also called default gateway. Default gateway is also referred as gateway of last resort, which means that route in the routing table would be used when it doesn't find. It finds no other routes that are valid. So, okay, no other routes that are valid. So here, let's configure in a router R1. So to configure the route, we need to go to global configuration mode. Now we can configure IP route. Okay, and we need to add the destination prefix. For the default route, we give destination prefix all or 0. Okay, which means which represents everything else, all uh, networks, all IPs. Okay, what is next? Next one is destination prefix. Destination prefix mask means subnet mask or network mask. That would be /0. Okay, So we give that thing as 0 as well. And next thing is where to go. You either give a network or you give the forwarding router's address, which means either you can provide any one of them. You can give the interface or you can provide next hop. So here next hop would be 170. Next, no, yeah, 10 dot. Next hop would be 10 dot 5 dot 0 dot. No, one is a router R1. Yeah. So two is a R. Okay. Yeah. Okay. Now, yeah, I have given mask which is 0.0 is for a default gateway. Okay. Now show IP route. Okay, which is a star, which is default gateway we configure. Now let's check if it is working. From here to here it should go. Why is it failing? Dot 5.0.2. No. Okay, let's do one thing. It should work. But how do you invalidate something? How do you invalidate something? Okay, I have typed this, and you don't want this thing to you don't want to remove. You just have to type the same command, but put no this before that. Now do show IP route, which removes that router entry from there. Okay, we can enter this way. IP route and which is a destination prefix. Destination prefix would be 172.18 dot 18 dot 32.0 and 252 and the next hop address is 10.5.0.2. No, do show IP route. Do show IP interface brief. Okay. So this Ethernet address is, you can see FS01 is 5.5.1 and Ethernet, and we are sending it to 5.2 for the network 172.18.32.0. Okay, so now, okay, now for this router, configure the same net, same thing, conf T. So we have to configure here, do, what do we need to configure? The same route again here, the reverse. Okay, so IP route, the destination network 192.168.5.0 to 12.2.2.0, and where to go? It should go to 10.5.0. Sorry, 10.5.0.1. Okay, and so do show IP route. Yeah, it should work. And basically here it didn't work before or after we added default route, probably because we haven't specified the return path. Now it should work. Yeah, here it is working, as you can see. For that reason only it was not didn't work, because we added default route here in router R1, but we haven't specified the return path. So it should be proper route should be there in R2. That is the reason it didn't work. But anyway, we added the route for the specific network. That's fine. We can replace that with the default route, even though now it works. Just let's go on with that now, and let's check how is it going. So it is working now. Let's run let's configure. This is a server. Go to the service and let's check if HTTP is working on. Yeah, it is enabled. Now let's go and open the browser. Open this one. This is, and go to the web browser. Okay. Type server IP, which is 172.18.32.2. It's working. No, you have, yeah, no, you have to, if you want to invalidate any command, you have to type no before that command. Type that whole command again, just and put no before that. Okay, and I'll show you again. But now check the router IP. Router IP. If uh, router IP is 10.5 dot, okay, 0.2. Okay, server reset connection, it is not working. Now one thing here, probably we don't have to use here. Thing is that, let me go and reset this router, because since we are using NAT, this is the private IP, we don't have to be able to reach this web server 0, because if you set the NAT, all we have to do is reach out this 172.168.10.5.0.1, this public interface. Let me copy this and add this. Ten dot five dot zero dot. Okay. Yeah, we don't have to reach out to that. So yeah. So thing is that the whole goal of NAT is, here we have this right. So we should be able to reach access that web server using this public interface. 10 dot, sorry, it is 2, right, not 1. Okay, so reach out to that using 10 dot, that is actually publicly which is outside for this router R2, which is inside loop. Okay, here we are implementing on R2, we are implementing the NAT. Okay, so here it is not working. So what happens if you use the static NAT? What happens? We are mapping this 10.5.0.2, which we are mapping with that with 172.18.32.2. Okay, so Now let me configure this default route here. Okay, so and let me invalidate. Okay, here is what it is. Show IP route. What do you have? That static route is added. So what happened? This is the route I have added. See the IP route 170.18.32.0 to okay. So I'm invalidating that, just putting prefixing no, and now you won't see that. Now I'm adding a default route. IP route 0.0.0.0.0.0.0.0.0. Okay, IP route, and then what is destination? It should go to. It should, yeah, we can provide the interface. We can provide the destination, or we can provide the interface of that corresponding router as well. Okay. Do now check do show IP route. Okay. Yeah, it's working. Now just validate that if it is working or not. Go here. Oh, it is not working right. Yeah, it's working. Okay. Sometimes, for the first time, this tend to fail because of ARP. Okay. Surface resolution. Now, still, am I able to reach? Just check. I can go here to desktop and see. You can also ping that one. Ping 10.5.0.2. It's working. Okay. Now, let's configure this router. Take router R2. Configure NAT on that. See, here you can confirm that NAT is not working. Why? Because if I go to web browser and if I type that global inside with respect to the router R2, I'm not getting anywhere. 10.5.0.2 because this is I'm checking this one from PC. See, this window is from PC. Okay, this is from router R. Now configuring the route. Configuring the router config. Okay, configuring what? I'm configuring NAT here. So, what is the command to for any configuration? You know the drill. We should be in a global configuration mode. That I'm inside that. There is a command called IP-NAT. IP-NAT, and you have to specify here inside outside. Okay, inside address translation, outside address translation. Okay, so I'm translating inside source. Okay, what is the source? Here, source can be a list of IP addresses, or it can be a static. Specify static global and mapping with a global. So here I'm specifying static, and what you can specify here after static, you have to specify inside local IP address. What is inside local IP address? Which is the server IP, which is 172.18.32.2. And after that, No. I'm specifying. See, remember the NAT I'm specifying doing here. NAT. Here is I'm implementing NAT here. Okay. Okay. Let me type something here. Okay. On this here we have a NAT. Okay. This is where I'm implementing NAT. Got it? Okay. Hello. And take this one. Inside source static. Okay. Which is inside private address, and now we should map with the global address. What is the global address? 10.5.0.2. And now check show IP NAT. It is low privilege exit mode command. Show. Okay. So I specified that one. After that, it is not done. We have to tell more about router, but go and check show IP NAT translations. Okay, I have specified that inside and global, and if NAT is working, you should see statistics. Show IP NAT statistics. Okay, it is not yet done. So conf terminal, just go to the configuration. We have to do more. What is more? We have to specify. Of course, we specified so static. We mapped local to the global one that you can see here. Global according to the router R2, according to the server, global is 10.5.0.2. Now here configure interface. Okay, we need to configure interface. Tell the router what is local, what is global. So here FA0 is inside. Okay, so interface I'm selecting FA0 0. Okay, and IP NAT. So what is that? That is inside, right? Now exit and tell and configure the which interface is outside. What interface is outside here? You can see here FA01. Local inside, local outside. Okay. IP NAT. So select here interface. Now interface FA01. Okay, which one should we select here? FA01. Now tell this, of course we selected the FA0 interface. Now configure this as a IP NAT outside. Okay, so done. Now let's exit. Now configure show IP NAT translation. Okay, show IP NAT statistics. Okay, see, now you see once it is there, and if it is up and running, you will see some statistics. How many are there? Like, now go and check this. Go. Now you see here, surprisingly, now we are getting the website. Now we are getting the website, right? So by using the IP address of router, router public interface 10.5.0. Okay. See, I haven't used the IP server IP, which is 172.18.32.2. Where I used instead of the server IP, I used the router IP 10.5.0.2. It is translated into the server IP, and so this router forwarded that to the router after translating this IP, replacing this public IP. Uh, Here in this case, our scenario, but that is not actually the public IP, that is a private IP. But the public interface IP, this is translated into private, and that packet is forwarded to server. And when server is, that packet came back to router R2, and the translation happens. But if you go and check this, so IP NAT translations, you will see now configured inside global, inside local, and the same as the outside global and outside local. Okay. Now it is done. Uh, Now let's see. Go to the let's go to simulation, and let me show all none, and let's select only HTTP to show you NAT in action. Okay. To show you NAT in action. Now, this is from PC0. Click go. Okay. It started simulation. Now click go. Okay. You see here the HTTP packet is constructed. Now it is moving. Let me fast forward this simulation. Now once it is received here, from here it is received by server. Then it is received by router R2. And once router R1 is received, let me pass this thing and let me check what is what here. When packet is last device, let me check this, what's going on here. When packet is received by PC0, sorry, this is constructed by, okay, when packet is, let's check when it is R1. Yeah, it is the R1. Okay, so what is the source address, which is 19.168.5.0, and the destination address is 10.5.0.2, and which is the same for the out layer when packet is leaving the router R, which is 10.5.0.2. Okay, and but at router R2, you can see here 192.168.5.4 as a source address, but as a destination address 10.5.0.2, which is when packet is received by router R2, which is in layers and out layers. But check, here is the NAT magic. When it is leaving the router R2 with the map translation, you can see source address haven't source address didn't change, but destination address, which is translated or mapped from 10.5.0.2 170.18.32.2. So this is since destination IP address is translated, mapped, destination public IP is translated to private IP, or destination IP is translated. So we call this as a destination map. And when packet is reached the server, same thing happens. Source would be same, destination is here, the server IP. But when it is leaving the server, of course, destination and source will be swapped. The source would be the 32.2, destination is 5. When it is reached the router R2, when it is reached the router R2, you can see here source is 190.18.32.2, and which is the in layer, and destination is 5.4, it doesn't change. But here, so when it is leaving the router R2 did the magic again. It translated, it mapped the private IP it has with the public IP or the global interface, which is sorry. No, it is not a public IP, private IP in our configuration, which means that it is mapped with the, but in a real world scenario, it would be mapped with the public, actual public IP. Here it is, we haven't taken the public IP here. The all IPs we have taken from the private IP box, but in real world, in your home router, it would be mapped with the actual public IP. But sometimes if your ISP is providing the block from the one of the private IP, there it would be mapped with the uh, your local private IP block to the IP of the ISP. Something that sometimes that might be private IP, but for the demonstration purpose, we have taken all IP addresses from the private IP blocks. But so here it is mapped to the global interface, which is FA01, which is 10.5.0. Okay, and here it is. Now it is back to normal. Okay, this is how NAT works. I hope you understood.